Hello and welcome to Talking Defense, Rafael's Defense magazine. Every program will be dedicated to a different subject with all relevant experts, data and aspects here in the studio and from around the world. And today, electro-optics. With me in the studio is Gideon Weiss, Vice President of International Business Development and a former IAF fighter pilot. And via Zoom joins us Netanel Ratner, Chief Technology Officer of Computer Vision and Electro-optics. Thank you so much, gentlemen, for joining me today. So we'll start with you, Mr. Ratner. What exactly is electro-optics?
Well, yeah, an electro-optics system is essentially a fancy word for a camera. In our case, a very high-end camera, and respectively, electro-optics is the field in engineering for designing and planning such cameras. It involves knowledge in mechanics, physics, optics, control theory, hardware, software, algorithms, and so on and so forth.
And what exactly do you do with it?
Well, essentially, we mount it on a fighter jet, and then I think Gideon would be the best man to tell you about that.
So head on to you, Gideon. You were a fighter pilot. Using that in the sky, what does it give you?
So electro-optics are used in air-to-surface weapons, in air-to-air weapons, in surveillance cameras, reconnaissance pods, but even on the ground. So there are many uses for them, and depending on the mission, and we can look at the history of where these systems were 40 years ago, 30 years ago, to what they are today. They are all over the spectrum of missions, and we can talk about some of the uniqueness of them.
So let's talk about it. I mean, you're a veteran fighter pilot. You started when electro-optics were at one place, and currently a whole different game.
Correct. I think in my lifetime, we have seen the biggest transient in electro-optic improvements and evolution, if you will. If you take the air-to-air missiles, they were just heat-seeking missiles. They are completely no longer that. They are imaging seekers. They see the camera, they see the enemy, they can tell what is the background and the enemy airplane. So air-to-air missiles have evolved completely. The reconnaissance missions, for example, they were just cameras looking with celluloid tapes. Now they're all digital. And so the transition was all in the last about 40 years.
And Rafael is maybe the world's leader in that field, way advanced compared to nearly everyone. Why so?
I think what makes Rafael different is the fact that we don't just operate in one of the world's most contested areas, but we have a very interesting array of people. We have people who are active in the IDF as reserve people, and we have the engineers. So we understand the mission sets and we understand the technology. Sometimes it's the mission sets that define the technologies, and sometimes new technologies enable new mission sets. And I think maybe Netanel can elaborate on that.
So back to you, Netanel Ratner, by Zoom. Tell us a bit on that field, and more than that, what makes your technology so unique and why others are not able to copy that?
Well, as I've told you before, electro-optics is a field in engineering that is highly multidisciplinary. That means that everything needs to be orchestrated together, and the differentiator of Rafael is in its system engineering. We have system engineers with very thorough understanding of the entire set of engineering fields required to optimize an electro-optic system. Therefore, our systems are optimized for the specific mission involving all disciplines and engineering fields, again, optimally orchestrated together as a whole system.
And if I ask you, where is this world heading to? I mean, Gidi here said that in his lifetime, and he's relatively young, he saw such a huge revolution in that field. So where's the future?
Well, there are two parallel trajectories that the technology is heading. First and foremost would be the physical trajectory, and the capabilities increase linearly with time. That is to say that the resolution of the image sensor increases, the quality of the optics increases. But I think the revolution is not in the physical manner, but it's rather in the algorithmic aspect. We supplement our systems with artificial intelligence capabilities, which transform the functionality of the operator, namely the pilot, from operating the systems to become a decision maker. So the algorithms, the artificial intelligence algorithms, handling all kinds of all kinds of operations that have been previously performed by the operator, such as target tracking, and they're now being conducted automatically, converting the pilot to be a decision maker rather than operating the system.
So back to the pilot here in the studio. I mean, in the past you were warriors. Currently, the laugh is that you became drivers, because the airplanes and the technology is so much advanced, as we heard, that nearly the airplane and the technology can do nearly anything by itself, mainly onto the new world of AI.
Well, I think that the complexity of missions has been sustained, but what we can achieve from these missions is far beyond what we could have dreamt a few years ago. When you look at exactly what Nathaniel has said, how do you take better optics, better resolution, higher capability of computing into a mission set is completely different. So these technologies on their own, just to talk about the technologies, don't necessarily give you the mission set. But when we take them and put them in the new capabilities, when you look at the large aperture of the Lightning pod, it's the ability to see and recognize targets from about 100 kilometers. When you put it in a Reiki-Light XR, it's the ability to see with better resolution and identify targets in the same mission. And it's also the ability to house everything and miniaturize it into something so small as a microlight, and then completely have ownership of an entire area, looking at the entire area all the time.
And I'll ask you what I've just asked Nathaniel. Where is this world heading to? I mean, if I take you now 10, 20, 30 years ahead, what's in the future in this industry?
So I think these technologies will take the mission sets into a place where the operators will be at a much higher place, as you said before, in the position of they don't necessarily need to operate the system, but they'll make decisions. They can make decisions as to bigger picture of the mission, and there would be more autonomy. There would be more solutions made for them in real life, and they'll be able to make decisions in real time and then convert them into a more efficient, faster, and a more complex mission. For example, if there would be a way to have an autonomous aircraft or UAV fly with a manned aircraft, there would be a manned and unmanned. That's a trend a lot of nations are already talking about. So when you combine that capability, then the manned aircraft can do many more things because all of these unmanned can take more risks.
So now I'll ask you the toughest questions. Who are the potential clients? Because we're talking of a very delicate and sensitive and in a way secret technology that obviously Rafael and Israel won't share with everybody, but still we have some friends that maybe we want to assist with winning their enemies. So who might be interested in such an advanced technology?
I think most of the defense forces around the world, may it be air, ground, naval, and even space, have the interest to use electro-optics in different levels. And it really is a matter of the complexity of their missions that would determine what type of technologies they would want to apply from what we have. For example, very advanced nations need to operate in contested areas where there is no GPS. How do they navigate in that? We have a solution in all of our systems that enables electro-optics to provide navigation solution. So that is one type of an example of what these customers can use when they apply this or that. Some customers have just an accessory to map or to take reconnaissance or to do something more simple just because they don't have that requirement or they don't have the budget. So we can tailor that to what these customers want.
Gideon Weiss, Nathaniel Ratner, thank you so much for joining me today. And that's all from us today. We will be back shortly with another edition of Talking Defense. Until then, stay safe and stay tuned. Bye-bye.